So looking at this next example, it says given parametric equation x equals to cos 2t and y equals to sine of t, given t is an element of real numbers, A, find Cartesian and vector equations of the curve, and B, hence sketch the curve. So we'll start with A, over here. It says Cartesian and vector equations. To find a Cartesian equation, x equals to cos of 2t. Cartesian equation will be writing y in terms of x, correct? Cos of 2t, trigonometric identities, we can understand cos of 2t is cos squared t minus sine squared t, but cos squared t can also equal to 1 minus sine squared t. So this then, there's three different identities for cos 2t. Obviously you've got the cos squared minus sine squared t, cos squared t minus sine squared t. But we can write cos squared t like we mentioned earlier, 1 minus sine squared t, sine squared t minus sine squared t, which then equals to 1 minus 2 sine squared t. Correct? Replace this and write it in terms of t. So x minus 1 all upon negative 2 would then give me, this would then give me 1 minus x all upon 2 equals to sine squared t. Write this in terms of sine t, take the square root of both sides, so y then equals to square root of 1 minus x all upon 2, correct? If we square that again, square both sides, we can rewrite this as y squared equals to 1 minus x all upon 2. And this is going to be defined between negative 1 is less than or equal to x, which is less than or equal to 1. Why this is the case? Because in a cos graph, look at a cos graph over here. If it's a 1, its range for a cos graph is only defined between negative 1 and 1. Correct? So for any value of t we get, it's only going to be defined between 1 and negative 1 over here. Cos 2t, if the 2 was outside of the cos, that's when the amplitude gets shifted. If it's inside the brackets, for example, we write it as that, the period of the graph gets, in a way, it affects the period of the graph, not the amplitude. So it's only defined between negative 1 and 1. Finding the vector equation of the line, again, vector equation we can rewrite as r of t equals to, in this case, x of t I plus y of t j, correct? X of t is cos 2t, cos 2t I plus sine of t j. With, so this is defined with t greater than or equal to 0. So this is how you do A. Now let's sketch this graph over here. Now that we come back to B over here, we know that this graph is only defined between negative 1 and 1. And looking at this is going to be a sideways parabola. So let's try and quickly sketch this up over here. We have y, we have x. Sideways parabola, only defined between negative 1 and 1, so we can put 1 over here. 1, negative 1. Sideways parabola, it's going to be something like looking like this. It's going to stop at negative 1 with a closed circle, sorry. Yeah, and the same thing over here. This is what you get, and we can finish off with the terms 1, 0. This will be negative 1, 1. And this is going to be negative 1. So this is negative 1. This is going to be negative 1 and 1. over here. From this point, if we have close consideration of this, let's just say a particle starts over here at point 0 when x equals to 0. You know that it's going to retract, it's going to move towards this point. Let's just say this is point A, point B, and point C. Since the restrictions on x have been given, as t increases from 0 to pi to 2 pi, this graph is literally going to go to A and retract back to B, go to C and retract back to B again. It's going to continue that same cycle since we developed that x was defined between -1 and 1. So that is how you do this example over here. Now we'll move on to the next example.